All right, so you know how much we love digging into the tech that's shaping the future.
Absolutely.
Well, today's deep dive, we're taking that pretty literally
Okay.
to the skies. We're talking drones,
Uh,
but not just any drones.
yeah.
We're talking about drones that can pilot themselves
Oh, wow.
with PX4 autopilot.
Okay.
You sent over a bunch of articles and research on this, and let me tell you, this stuff is next level.
It really is fascinating how much progress is being made.
Right. So for anyone who hasn't geeked out on drone software before,
Right.
let's start with the basics.
Okay.
What exactly is PX4?
So PX4 is open source flight control software, but it's bigger than just lines of code.
Okay.
It's a whole ecosystem.
Okay.
Think of it as the brains behind some seriously impressive autonomous drones and other unmanned vehicles.
Okay, open source. That always piques my interest. It's like the Wild West of tech, but in a good way, right? Does that mean anyone can contribute to PX4?
Exactly. It's developed collaboratively under the umbrella of Drone Code, which is hosted by the Linux Foundation. So you've got some serious coding power behind it. And yes, that open source nature means anyone can contribute code, improve documentation, or even build compatible hardware.
That's really cool. It reminds me of like those early days of Linux where passionate people came together and ended up revolutionizing the tech landscape.
There are definitely parallels there, and this collaborative spirit is a big part of what makes PX4 so innovative. What's really fascinating for developers is the modular architecture of PX4. See, it allows them to easily swap out components, add new sensors, customize it to their needs, kind of like building with Legos, but for drones.
So it's like Legos for drones. That's cool and all, but what does that actually let someone do? Can you give me an example of where this modularity makes a real difference?
Imagine you're a company that wants to use drones for agricultural monitoring. You'd need specific sensors and cameras to analyze crop health right. With PX4's modularity, you can easily integrate those specific components without having to build everything from scratch. This flexibility saves time resources and ultimately makes these applications more accessible to businesses and researchers.
Okay, now that is seriously cool.
Yeah.
So we've got this powerful, customizable system.
Right.
But there's another term I keep seeing, autonomy stack. What does that mean in plain English? Are we talking about drones that can basically fly themselves?
You got it. The autonomy stack is all about enabling drones to make decisions and navigate without constant human input. And a huge part of that is computer vision. Basically, it allows drones to see their surroundings, process that information, and make decisions based on what they perceive.
Okay, now this is where it gets really wild. I'm picturing self-flying delivery drones navigating through cities like something out of Blade Runner. Are we getting ahead of ourselves here, or is that level of autonomy really within reach?
It's closer than you might think. PX4's autonomy stack, combined with advancements in computer vision, is making those scenarios increasingly possible. We're already seeing autonomous drones used for things like package delivery, infrastructure inspection, and even search and rescue missions.
That's incredible. But with all this autonomy, there have to be some serious safety measures in place, right? What happens if a drone loses signal or encounters unexpected obstacles?
Absolutely. Safety is paramount. PX4 has built-in fail-safes for these exact situations. For instance, let's say a drone loses contact with its ground station. It can be programmed to automatically return to its launch point or land in a safe, predetermined location. PX4 even supports additional safety features like parachutes for those just-in-case moments.
That's good to know. It sounds like a lot of thought has gone into making sure these autonomous drones are as safe as possible. Now, one thing that really jumped out at me while going through these materials is that PX4 isn't just for big tech companies or research labs. There's a whole DIY build section, which makes it seem like anyone can get their hands dirty building their own drones with PX4.
You're exactly right. PX4 is surprisingly accessible, and that's another thing that makes it so exciting. The PX4 user guide is incredibly comprehensive, covering everything from hardware selection to software configuration. It's like a treasure map for anyone who's ever dreamed of building their own drone.
So you're saying that someone listening right now with a bit of technical know-how and the PX4 user guide could potentially build and fly their own autonomous drone.
That's the beauty of it. And this open accessibility has led to a vibrant community of hobbyists, students, and makers who are constantly pushing the boundaries of what's possible with PX4.
You know, it's funny. We often hear about AI and automation taking over jobs.
Right.
But PX4 seems to be doing the opposite. It's like it's opening up this whole new world of possibilities,
Yeah.
creating new industries and opportunities that we haven't even thought of yet.
Yeah. That's a really interesting point. And it's not just limited to drones either. We see this happening across many tech fields. As the tools become more powerful and user-friendly,
Right.
it empowers individuals and smaller companies to achieve things that previously only large corporations or governments could. It's really democratizing innovation.
It's like the invention of the printing press all over again, right? Knowledge and the tools to create are no longer exclusive. Speaking of knowledge, I want to circle back to something you mentioned earlier, drone code and the Linux Foundation. What's the connection there and why is it important?
Right. So PX4 is developed as part of Drone Code, which is a nonprofit hosted by the Linux Foundation. This basically gives it a stamp of legitimacy and shows a real commitment to keeping it open source.
So it's not just a handful of developers working in isolation, there's a whole support system behind PX4.
Absolutely. That support is essential because it allows the core developers to focus on the core software, while the community can contribute to things like documentation testing and even building out hardware compatibility. It's a beautiful symphony of collaboration.
And that's the magic of open source, right? You're
Mhm.
tapping into the collective brainpower of a global community, leading to faster innovation and a more secure and robust system overall.
Exactly. This collaborative spirit is reflected in how PX4 is designed, too. We've talked about its modularity, but it goes deeper than that. Each module within PX4 is responsible for a specific function, like navigation, control, communication, you name it.
So it's like a well-coordinated team with each member playing a critical role in the overall success of the mission.
Perfect analogy. And this modular approach makes it easier for developers to contribute to specific parts without needing to understand the entire code base. This also means you can develop specialized modules for niche applications, which expands the possibilities of what PX4 can achieve.
This brings us back to what we talked about earlier. Drones, delivering packages, monitoring crops, exploring underwater.
Mhm.
It really seems like with PX4, the only limit is our imagination.
I completely agree. That's what makes this such a thrilling field to be a part of. We're witnessing the birth of a new era in robotics and automation, and PX4 is leading the charge.
It really does feel like we're on the verge of something incredible. It strikes me that what we're talking about here is more than just like a cool piece of software. It feels like a genuine paradigm shift, almost like the early days of personal computers, when nobody could have predicted the impact they would have.
It's an apt comparison. Just like with PCs, PX4's potential lies in its open and collaborative nature. When you empower people with powerful tools and the freedom to experiment, incredible things happen.
There's like this incredible feedback loop of creativity, right?
Yeah.
One team might build a module for precision agriculture,
Yeah.
while another creates a drone for search and rescue, and then those innovations get shared with the community, pushing the boundaries even
Yeah,
further.
precisely. It's a ripple effect of innovation. And that's what's so exciting about PX4. It's not just the technology itself, it's the community driving it forward.
This snowball effect is so powerful. More people using PX4 means more contributions, which leads to a better system, which in turn attracts even more users. It's a virtuous cycle.
And this open approach stands in stark contrast to closed systems where innovation is limited to a select few. With PX4, anyone can contribute regardless of their background.
Which brings us back to that DIY build section. It's amazing that PX4 is accessible to hobbyists, students, really anyone with a passion for drones.
Absolutely. It lowers the barrier to entry and lets anyone experiment and potentially contribute to the field.
And let's not forget the educational value. Building a drone with PX4 isn't just assembling parts. It's about understanding robotics control systems and software development.
Exactly. PX4 isn't just for building drones, it's a platform for learning and pushing the boundaries of what's possible with autonomous systems.
A gateway to a whole new world of exploration. As we wrap up our deep dive into PX4, I'm left with a real sense of awe. This open source ecosystem has the potential to revolutionize not just the drone industry, but countless others.
That's the beauty of technology at its best, the power to transform our world in ways we can only just begin to imagine.
So to our listener out there, we leave you with this. With PX4 evolving every day, the drone industry booming, what will you create?